Welcome to the session on batch geocoding. So loud in here. I'm Bruce, and with me today is Victor, in case you couldn't guess which each of us are, and there's our email addresses to follow up with after the show. I'm a product manager in the desktop group in Redlands, and I have been involved with geocoding for a number of years. It's one of my, I guess, specialties, you would call it. Victor is a developer actually on the geocoding team. Now, obviously, there is a geoprocessing tool that ships with core desktop that does batch geocoding, and we're not really here to talk about that today. We're going to talk about coded approaches. So these will be ways you'll see how to accelerate your geocoding in desktop and server and online environments, not so much just using the out-of-the-box software. So without further ado, we've got a mixture of slides and demos. We'll get started. So your next half hour will be a review of out-of-the-box best practices, really confining our discussion to ways to tune locators that you can do yourself. So that's your onboard in-house behind the firewall locators. So the coded approaches you're going to see are using ArcGIS Pro standalone, and what you will see, one of the approaches I'll show will also work in ArcMap. So that's a couple of ways to do things on the desktop. And both Victor and I are going to show hitting the REST endpoints available from ArcGIS Enterprise and ArcGIS Online to do batch geocoding with a particular call that's available there. I'll sit down now so I can see what's going on and drive things. So complete off-the-shelf desktop best practices. There are some basic rules that you can benefit from by applying. Firstly, we do recommend use ArcGIS Pro. The 64-bit memory headroom greatly benefits geocoding speed if you've got a local locator, because they're pretty heavy-duty slices of memory that are used by the locators, and the headroom you've got with 64-bit environment helps a lot. Now, the main thing you can do, if you have the option that will accelerate your geocoding without doing any extra work at all, is to sort your input data on the zone fields. So in the US context, if all you did is sort on zip code, you're going to accelerate your geocoding by 30–40% easily. The reason for that is the locators, and including locator services, are spatial indexed, and the access to locators goes in through the zone fields. So I'm finding 123 Main Street in some town, and I know the zip code. The locator knows by the zip code which part of the index structure to go and look into. So putting things which are nearby spatially, nearby in your table input, will give you a significant speed up without you having to do anything extra. Solid state disk is a good thing to use when you're storing your locators, and even, in fact, all your work, because the access rate for the paging and what have you is so much faster in solid state. Locators have a memory footprint. You probably can see how big they are on disk. If you have the luxury of allowing that much RAM that you see on disk for the locator, then the entire locator will be in memory, and there's much less work for the computer to do. Lesser known, and perhaps a path less trod, is that geocoding is multi-threaded, or can be. You need to switch that on. So two ways to switch that on. If you're using a single locator, there's a thread count option in the locator properties, and you can set that to auto. Then the system will sense how many cores you have and use one less than the total. So one core will be left to handle the data handling, and the rest of the cores will be used by threads to do the geocoding. Now, composite locators, you can't leverage that auto property, but you can assign the number of threads usable by each member of the composite. We'll see where those properties are set in a moment. So if I went to disk here and I looked at the LOC files, which define the properties of locators, I can look on the right-hand side there. You see the locator properties dialog that you would get in ArcCatalog or the catalog window in ArcMap if you right-clicked on the locator itself and brought it up and looked at performance. And I put a little red ellipse around the number of threads is set to auto. Now, this is something you can only do with file-based locators, but those are the only ones we do support at 10.5 and forwards. So that's always going to be available for you for the locators on disk. There's a fairly modest amount of RAM set for that particular locator. It didn't happen to be a very big one. It's only 488 megabytes of RAM. So that's an individual file-based locator. You can set those properties with the properties dialog. On the left-hand side of the slide, I've taken out some little snips of Notepad there. I've been looking at rows in the LOC file that defines the composite. If you look carefully, you'll see that for each member of the composite I've clipped out to show, there's a number of threads property. So my machine has 8 cores, and some other ones like postal zone and stuff in the composite. I divided up the available cores to a total of 7, and I assigned 2 of them at the busiest locators. So the point address and street address is where I'm hoping to catch all my geocodes. So I give those members of the composite 2 threads each, and the other ones take 1. And the very last line in the slide there and in my LOC file is I turn multi-threading on for the composite locator. So from that point on, ArcGIS knows to use the certain amount of threads I've assigned per member of the composite. So that's as far as we'll go in what you can do, tuning locators and tuning your data. So you sort your data by zone field, and you turn on multi-threading, and you allow enough memory. Then you should be able to leverage the locator itself a number of ways and most efficiently. The first way I'm going to cover, because this is a coding show, in fact all of our options are going to be Python based, I'm going to show how you use subprocesses. Now, subprocesses are full processes in their own right. It's like running another session of Pro or Catalog, whatever you happen to have spawned it from. So it knows about full ArcGIS, but it works independently. So they get their own set of resources, such as memory assigned to them to do their work, and they do their job equivalently. So you really do get some acceleration, provided your computer is up to the task. So this example, I'm using subprocess module in Python, and my strategy is to make job workspaces, which are file geodatabases, so I can work independently with each of those. I make table parts. So my input table to be geocoded, I end up splitting. I split it evenly into the count of workspaces that I've created. I geocode each of those parts in individual subprocesses, and after they're all complete, I merge all the parts together. And that's literally using the merge geoprocessing tool. Obviously, this approach has some overhead. I'm splitting a potentially big table. That takes some time. And I'm merging a number of results together, and that takes some time. So that's the overhead. However, it does achieve significant gains for big jobs, and that's what we're trying to do here. We're getting a lot of leveraging of a modest cost platform. So one desktop machine, if that's what you've got, you can use all the cores simultaneously. So it's very cost effective. Not cost effective in terms of CPU cycles, you get a lot of those burned, but they're free, right? Essentially, you've already got that sunk cost. What you're not having to do is buy extra computers. So on the right there is some code. We'll go through my Python code. I'm a product manager, so you might think it's ugly. Victor's code is going to be much better looking, but it functions, okay? And you can get hold of it. After the show, feel free to look for this sample. Just look for subprocess geocode in ArcGIS Online. Do check the box for searching for desktop content. It'll be there. So let's go for a demo. Gentleman here earlier asked, are we going to show things in ArcMap? We're going to use Pro. So here I am in my project, and there's my subprocess geocode tool. I'll keep my word here, and we'll edit in idle, my preferred IDE. It's probably, all the professionals were horrified, but here we go. So the subprocess module is imported. I move on down here. I create expressions to define chunks. That's splitting the table. I create some workspaces and commands. Okay, so I'm making file geodatabases. And then I make a list of commands which are going to be run. It's as if I was at the command prompt in the computer, in Windows. And I launch the subprocesses, and I make sure I use 64-bit Python for the subprocess, and I wait till they're all done, and then at the end of the job, I call the merge geoprocessing tool. Let's do that. Get that guy up here. I set this up, well, I'm going to show the table. So 30,000 addresses. It's just a normal table. I've done what I said you should do. I've sorted them. They're all in Massachusetts. I've set the number of counts in the process to be something I know my computer can handle. 4, the chunk size is 7,500, and off we'll run it. So what happens now is the job directories are made, file geodatabases, and the computer obediently spins up the Python processes. They get busy, and I get good leveraging of my available resources. So there they go, working away. One's accelerating because it knows its auto thread count. It'll keep on boosting up. There you go. I'm really hammering the machine, but that's okay. That's what I bought it for. So after a while, the jobs will complete. They're starting to complete now, and we're waiting for the last of them to complete. We're merging the end result. And the job will finish, completed successfully, and the points arrive in the map. So what did I end up getting? I got just over 2 million per hour. If I did an even bigger job, I'd get in the significantly more millions per hour for no more investment than a copy of Desktop Basic and a little bit of code. So that's that example there. Let's go on now. How do we do even better? So geocoding is an embarrassingly parallel problem. It doesn't matter to the result which order we do any particular row geocode in. Python 3 is embedded in what we ship with ArcGIS Pro. Python 3 includes a module called Concurrent Futures, and that supports asynchronous execution of callables. So you can tell callables or executables to go and do something simultaneously, and you can wait till they're each done, and then you do something with the result. The thing I'm going to call is a REST endpoint called Geocode Addresses, which is delivered by ArcGIS Enterprise and also ArcGIS Online. It accepts some JSON formatted input. It lets me leverage all the services that are available on the Enterprise instance or with ArcGIS Online. It's scriptable in Python, and that's what we're going to do. So I'm going to leverage or accelerate my geocoding by calling this endpoint. The strategy is not, or doesn't have any overhead. I'm not going to split a table up. I'm going to create an output feature class. I'm going to read the input table in zone field order. That's my tip, remember. So all the zip codes which are together will be processed together. I make record sets in JSON. I geocode them. A key thing is I interleave concurrent jobs. So if I'm saying I want to use 4 processes on the server, there are always 4 running until they start to finish the entire job. Then there'll be 3, 2, 1, none. So as each part arrives, I append it to the output feature class. The default that you'll notice when you publish a geocode service is that the batch endpoint will process 1,000 records at a time. So I'm going to go with the default there, process 1,000 records at a time, and it's not too big a packet to ship up and down the network off my computer, and everything should go really well. So using this approach, you can leverage the full power of your enterprise instance with no overhead. Again, I'm just using Pro Client here, so what it is, 6-year-old laptop. Nothing fancy at the client end, all it's doing is marshalling data. But the cost is, of course, you need an enterprise instance or use ArcGIS Online in that account there. What I'm going to show you, you can download the sample that does this. Last week there were 438 downloads so far. I'm going to show you hitting ArcGIS Online because I couldn't stand up an enterprise instance, but it's the same deal. Okay, back to ArcGIS Pro. This time I'm going to geocode this table. So there's some addresses there. I'm using single line geocoding this time just to mix it up a bit. You saw Australia, Canada, Germany, Spain, France, so there's Italy, data from all around the world. It's okay, ArcGIS Online can eat that. Over here, here's my script tool. Here's the module I said we're going to reference. There's a bit more to do here. I do things like check available credits and permissions and so forth, but really it's the same kind of thing. I'm going to send a JSON record set, which is a dictionary in Python terms, in a number of batches. I'm going to define a generator to read my input table. So I open up the generator in a sort order, which is a cursor. That's a search cursor, right? See that guy there? It's a search cursor. That's all it is. I build record sets of 1,000 features. I batch geocode each of the record sets with this function. That's a bit there, make a feature class. And I write record sets to the output. So all here. And a little tip here, if you do hit ArcGIS Online, if you try and use more than 4 concurrent threads, you'll get throttled, so don't bother trying. So here I am limiting the number of threads to 4. And the rest of it is I make a thread pool executor object up with the module there, and I make an initial set of jobs, which is 4, throw it down there, process the balance. So the pool of jobs, I wait for them to be done or not done. If I find the one that's done, I write the records out and I replace the job with a new single job. So I'm always going to have 4 jobs running. So at the end of the day, I do some stuff, and it also handles street intersections, but it's more. So let's just go right to it. We've seen the table, we've seen some code. My input table is going to be world addresses. I'm going to use a single line field. The address field is that guy there, and it would default to use USA. I'm going to go back here. I'm going to say there is a country field in there. I'll take any kind of result. There's a thing called a category filter, let you refine any of that. And I'm going to write to that feature class. So let's just get that going. Checks my credits. It's sent the 4 initial jobs out of that I'm allowing myself to run. There's only 7,000 records in the table. You can see as batches of 1,000 go through, I submit a new batch. It's waiting for the full 4 to finish. And there you go, I did 1.5 million per hour for 7,000 features output. And they will be the same color, which is not very helpful, is it? So let's make it a nice bright green color. There they are around the world. So that was some batch geocoding worldwide, hitting ArcGIS Online with a parallelized and accelerated experience with some, well, you don't have to worry about coding, you can just go and get the code yourselves. So that was my demo of those 2 approaches, and I think we'll hand it over to Victor now for his show and tell.
Awesome. Thanks, Bruce. Can everyone hear me okay? Yeah? Cool. So, as Bruce said, I'm Victor. I'm a developer on the geocoding team. And today I'll talk to you guys specifically about the APIs that you can use for batch geocoding. So specifically, the Geocode Addresses API, the BatchGeocode API, some technical details of each, and advantages of each one. And then I will show some demos of some applications that are using each of these APIs in action. So the Geocode Addresses API, you probably all know about this API. Whenever you stand up a locator service on an ArcGIS.com server, the locator service, if you click Allow Batch Geocoding, you receive this API. So you can call geocode addresses against any locator that you have the ability to geocode against. So it demands input and output of JSON. So it takes a JSON record set, and it geocodes only up to max batch size records at a time. So for the ArcGIS Online locator, that's 1,000. So the Geocode Addresses API takes in a JSON of 1,000 addresses and outputs you back the JSON of the same 1,000 addresses with results, XYs. And this API requires credits when geocoding against ArcGIS Online. So a code sample of calling geocode addresses. So I have this function in Python called Geocode Batch, and it takes a bunch of input parameters to geocode addresses. You'll see I have an arrow pointing to token. So basically, anytime you hit a locator service that's on a secured server, so if the locator service is secured, then you do need to pass a token. So the only time you wouldn't need to pass a token is if the locator service is shared with everyone or it's public. Next, you'll see I'm passing the values in JSON format. So the record set is a record set of under 1,000 addresses. And you'll see I am also passing category and source country. And those are specific only to the ArcGIS Online World Geocoder, but a lot of locators that you'd publish on your server wouldn't have those parameters. You'll see I'm doing some client-side error handling. So I say, make the URL request and open it and give it a timeout of 90 seconds. And if you do get an HTTP error, then retry the request. So basically the way I would retry the request is I would cut the record set in half and send the first half up to Geocode addresses and then send the second half up to Geocode addresses. So that sort of error handling is the responsibility of the client for Geocode addresses. So finally, once you have the response, you would load it into JSON and then go off on your way. So now there are a lot of advantages to Geocode addresses. It is fast for small tables. So if you have under 1,000 records, this is a great option, I think. It's easy to debug. So Geocode addresses either passes back to you the records that you gave it or an error message, and it'll tell you exactly what's wrong. It'll give you 499 invalid token or 403 invalid category. So it's an easy API to debug for sure. It's lightweight, so anytime you publish a locator service to an ArcGIS.com server, you get the endpoint. It's free. It's free against your own locator service, but it's there. It's easy to use. It's available. And it is a synchronous API. So when you make the call to it, it is a blocking call. Now there is another API available for batch geocoding called BatchGeocode, which is new in 10.5. So I'll describe the new BatchGeocode API. So the BatchGeocode API is another endpoint for batch geocoding. It's a one-stop shop for geocoding large tables. So whereas the Geocode Addresses API a lot of the times only takes up to 1,000 records, this will accept your large table. And the way it works is it doesn't just take in JSON and output JSON, it accepts multiple file formats as input and output. So as input, you could input a CSV, XLS, or hosted table from your portal, and it can output back to you the CSV with the extra XY columns appended to it, an XLS file, or a feature layer. Keep in mind this API is portal only, so from portal to portal. So it takes the inputs from your portal and writes the outputs to your portal. And this BatchGeocode API leverages multi-threading for optimized performance. So basically you point this API at a specific geocoding service and you say, here's my table, here's the geocoding service I want you to use, and go. And this API geocodes the big table that you gave it against the geocoding service you told it to point at. Now there's obviously advantages to using BatchGeocode. There's more input and output formats, so it's not just JSON in, JSON out. It's got less error handling for client applications, so it's got this retry logic built in. So basically the only responsibility of the client is to call the API with the table and the geocoding service that you want to hit, and you let the API do the rest. So no matter how big it is, you don't have to do this chunking of your table and sending off different amounts of records to the API. It's robust, so it's meant to handle large inputs, and it's asynchronous. So the way this works is the job actually processes on the server. So once you call the API, the job starts processing on the server, and it's the client's responsibility to go check on the job. So when you send it to the API replies back, oh, this is your job ID. And so you check the job ID every once in a while and say, hey, is my job done? Hey, is my job done? And the server will pulse back messages to you, oh, it's this percent done or this percent done. So the BatchGeocode REST endpoint is available in 10.5. You'll find it in your server manager. Under services, utilities, you'll see geocoding tools. That's where the BatchGeocode API is available. And you'll see it in your portal.
5 minutes.
And so I'll show a quick demo So this is technology that hopefully will be available in the next ArcGIS.com release. So this is specifically for on-premises portal. So you'll see when you go to the map viewer in an on-premises portal, under the analysis tab, you'll have a new tool called Geocode Locations from Table. So here it asks you to choose a locator from the locators in your portal. You browse to a layer. So let's say I want to geocode this CSV record set. There's 4,000 addresses in this CSV. And it auto-populates a field mapping for you. Then I choose an output format. So I want a feature layer out, so it populates on the map. And then I will choose an output name. So remember, the BatchGeocode API is input from portal, output to portal. So this will output in portal, and I click go. And you'll see I have my network protocol on the left. So I'm debugging this API call that's being made. So you'll see this call right there, the call to submit job. So that submit job call submits it to the BatchGeocode API, and it gives me back an item ID. So on the right side, you'll see I'll gradually get more and more calls, and I'm asking the server every time I make this call, hey, is my job done? Hey, is my geocoding job done? So let's fast forward a little bit. And we have the geocoding job all completed. So this is some technology that leverages the new batch geocoding API. And with that, we're almost out of time. So I will, at this point, ask for any questions from the audience. So we're working on it as of right now. We hope to get it into 10.5.1 on-premises portal.
The question was, is it going to be a standard feature?
Any other questions? Cool. We'll stick around for a little bit if you guys want to come and ask us individual questions as well. Thanks for coming.
I'm working in the ArcGIS Pro area for today and tomorrow, so any questions come by. Thank you.